Welcome to a slow, beginner-friendly lesson on lists in Python, made for absolute beginners. Lists begin today. Today we slow down on the most common collection in Python, the list. A list is an ordered, changeable collection of items. Many values inside one name, kept in a specific order, that you can change later. Strings, numbers, mixed types, a list holds them all. We will not go deep on every method yet. We answer one question: what is a list? By the end you recognize a list, understand its shape, and know why it is the collection you reach for first. The most common collection. Look at where you are. Until now, a variable held one value, one name, one number, one string. But real programs need many values at once: the names of every student in a class, the prices of every item in a cart, the lines of a file. A list lets you gather those many values under one name, in order, and work with them as a group. Of all the collection types you met in the overview, the list is the one you will use every single day. One name, many values. Until now, one variable held one value. Today, one name holds many. From one to many, here is the shape of a list in code. Compare a single variable, name equals Ada, one string, one value. Now names equals square brackets Ada, Grace, Linus, three strings inside one pair of brackets. One name, many values. That is the whole idea. Square brackets tell Python, this is a list. The items inside are separated by commas. Len of names gives 3, the number of items inside. We will use this shape again and again. Square brackets make a list. Think of a real-world list. A shopping list: milk, bread, eggs, written in order, top to bottom. A music playlist: song 1, song 2, song 3. A queue of people waiting: first person, second person, third person. All of these are lists in everyday life. Python lists work the same way. One name, shopping, playlist, queue, and many items inside, kept in the order you wrote them. The order is part of what makes a list a list. Just like a shopping list, a list gathers many values into one ordered row. That is the whole idea. Many in one row. Picture a row of labeled boxes side by side. Box 0 holds apple. Box 1 holds banana. Box 2 holds cherry. Each box has a position number, and the count starts at 0, not 1. This is the shape of a list, an ordered row of cells, each holding one item, each reachable by its position. The first item is at position 0. The second at 1. The third at 2. The order is fixed until you change it, and the positions let you reach any item directly. Positions start at 0. Creating a list is simple. Open a square bracket. Put your items inside, separated by commas. Close the square bracket. That is it. Fruits equals apple, banana, cherry inside square brackets. Python now sees a list. When you type fruits and press enter, IPython shows the list back to you. Type of fruits returns list class. 3 items, in order, ready to work with. Square brackets, commas, done. Brackets and commas. Order matters in a list. Apple, banana, cherry is not the same list as cherry, banana, apple. They have the same items, but the order is different, and order is part of what makes a list a list. When you write a list, Python remembers exactly the order you typed. The first item stays first. The second stays second. This matters because many real collections have a meaningful order, a queue, a chain of steps, a timeline of events. Order is part of it. Here is something that surprises beginners. The first item in a list is at position 0, not 1. The second item is at position 1. The third is at position 2. This is called zero-based indexing, and almost every programming language does it. It feels strange at first, but you get used to it fast. The reason is historical and tied to how computers address memory. For now, just hold the rule: counting starts at 0. The first item is at 0. Always. 0 first, always. In a list, order is not decoration. The order you write is the order you get. Order is yours. You read a single item by its position. Type the list name, then square brackets with the position number. Fruit square brackets 0 gives apple. Fruit square brackets 1 gives banana. Fruit square brackets 2 gives cherry. The number inside the brackets is called the index. 0 gives the first item. 1 gives the second. 2 gives the third. The index is how you reach into a list and pull out exactly one value at a known position. Index reaches in. How many items are inside a list? Use len. Len of fruits gives 3 items inside. Len of prices gives 4 items inside. Len is short for length, and it works on every collection type in Python. You will use it constantly to ask, how big is this collection? How many names, how many scores, how many rows. Whenever you need to know the size of a list, len is the function you reach for. Len counts them all. A list does not care what type of item you put inside. You can have a list of strings, names. A list of numbers, scores. A list of booleans, flags. You can even mix types inside one list, a string, then a number, then a boolean. And a list can hold other lists, a list of lists, like rows in a table. The list itself does not care. It just holds whatever you put inside, in the order you put it. This flexibility is one reason lists are so common. Any type fits inside. A list is not locked. You add, you change, you remove. It grows with your program. Lists are flexible. Here is a list with mixed types. Mixed equals eta, 36, true, a string, a number, and a boolean, all inside the same list. Python accepts it without complaint. Mixed square brackets 0 gives eta, the string. Mixed square brackets 1 gives 36, the number. Mixed square brackets 2 gives true, the boolean. This kind of mixed list is common when you describe a record, a person's name, age, and active status, all together. Mix freely. Here is a key property of lists: they are changeable. In Python we say mutable. Once you have a list, you are not stuck with it. You can replace an item at a position, change apple to apricot. You can add new items at the end. You can remove items you no longer need. The list grows, shrinks, and changes as your program runs. This is different from a tuple, which is fixed. Mutability is one of the main reasons lists are the everyday collection in Python. Mutable means changeable. Lists allow duplicates. You can have the same value more than once. 1, 1, 2, 2, 3 is a perfectly valid list, 5 items, some repeated. The list does not collapse them. It keeps every item, in the order you wrote it, even if some are identical. This matters when duplicates carry meaning: a list of answers where the same answer can appear twice, a list of votes where each entry counts. Sets remove duplicates, lists keep them. Duplicates are welcome. Think about what you can do with a list. 4 kinds of operations cover almost everything. Create, write the items inside square brackets. Read, reach in by position to look at an item. Update, assign a new value to a position. Delete, remove an item from the list. Create, read, update, delete, sometimes called CRUD. The next lessons go deep on each one. For now, just hold these 4 operations in mind: create, read, update, delete. 4 operations. Lists are everywhere in Python. Files, names, rows, messages. The Everyday Tool. The Everyday Tool. Here is a quick preview of all 4 operations in code. Create, fruits equals apple, banana. Read, fruit square brackets 0 gives apple. Update, fruit square brackets 0 equals apricot, the first item becomes apricot. Delete, del fruit square brackets 1 removes banana from the list. We will go deep on each operation in the next lessons. This is just to make the 4 words feel concrete: create, read, update, delete. A quick preview. Why are lists the most common collection in Python? Because they fit most situations. You have many values in a meaningful order. You want to be able to change them as the program runs. You do not need uniqueness, duplicates are fine. You do not need name-based lookup, positions are enough. Almost every program has data like this: a list of files, a list of users, a list of messages, a list of errors. When in doubt, you reach for a list. Lists fit most data. Quick comparison to the other collection types. Need order and the ability to change? List. Need to look things up by name? Dictionary. Need uniqueness, no duplicates? Set. Need order but the data should never change? Tuple. The list is the everyday choice when order matters and you want flexibility. The other types are for special situations. You will build intuition over time. For now, just remember: list first, others when you have a reason. List first, others when needed. Quick self-check. Can you say in one sentence what a list is? Can you explain why the first item is at position 0? Can you name the 4 operations: create, read, update, delete? Can you say whether duplicates are allowed in a list? If any of these feels shaky, rewatch the matching part. You do not need to know every list method yet. Today is about understanding what a list is. The how comes next. Say each out loud. A list in one breath, an ordered, changeable collection of items. You write items inside square brackets, separated by commas. The order stays as you wrote it. Items can be any type: strings, numbers, booleans, even other lists. The first item is at position 0. You can create a list, read items by position, update them, and delete them. Lists are the most common collection in Python because they fit most everyday data. The next lessons show you how to use them deeply. Ordered and changeable. What comes next? We go deep on using lists. You will learn many ways to create lists, not just square brackets. You will learn to read items by index, and to slice out a range of items. You will learn to add items at the end, insert them in the middle, and remove them by value or position. You will learn to sort a list, reverse it, and search for an item. The list becomes a tool you use without thinking. That is the goal of the next lessons. Deep dives next. Thanks for learning what a list is. Next we go deep on creating and using them. Lists begin.